So guys, let's start today's discussion on significant figures. So you must know that every measurement involves errors. So the result of measurement should be reported in a way that indicates the precision of measurement. The reported result of measurement is a number that includes all digits in the number that are known reliably plus the first digit that is uncertain. So certain digits plus uncertain digit. Reliable digit plus first uncertain digit. This is known as significant digit or significant figures. So if we say period of simple pendulum, let's say it is 1.62 seconds. It means 1 and 6. 1 and 6, it is certain. This 2 becomes uncertain. Okay. So the measured value, it has 3 significant digits. Got? Or you can say 3 significant figures. Let's take another example. The length of an object reported after measurement to be 287.5 centimeter. What about this? So it has total how many significant figures? 4 significant figures. So the digit 287, these are reliable or certain, and this is uncertain. So this leads to us to questioning how to determine the number of significant figures from such questions. So the rules for determining the number of significant figures can be understood from the following example. Significant figures indicate the precision of measurement which depends on least count of the instrument. One of the rule is a choice of change of different units does not change the number of significant digits. So the change of different units does not change the number of significant digits. Let's take an example. 2.308 centimeter. It has 4 significant figures, right? But in different units, the same value can be written as, let's say, this can be written as 0.02308 meter or 23.08 mm, or it can also be written as 23080 micrometer, right? So what is micrometer? It is 10 to the power minus 6 meter. All these numbers have the same number of significant figures. Okay, same significant figures, that is 4, right? This shows that the location of decimal point is of no consequence in determining the number of significant figures. So we can deduce that location of in determining number of significant figures. Now let us discuss the rules. The first rule is all the non-zero digits are significant. Significant, it means 1, 2, 3, anything. After decimal point also 2, 3, 6, 9. All the zeros between two non-zero digits are significant. All the zeros between two non-zero digits. This is significant. These zeros are significant. No matter where the decimal point is, if at all. So 1.002. So these are also significant. 200.2003. This both are significant. Third, if the number is less than 1, then what will happen? The zeros on the right of the decimal point but to the left of first non-zero digits are not significant. These, all these non-significant. This means the number has to be less than 1. So it can be 0.99. Okay, has to be less than 4. 12300. So these zeros are not significant. So 123 meter or 123 centimeter both have 3 significant digits, right? So the terminal or trailing zeros in a number without a decimal point are not significant. So decimal point should not be there. What about 123.00? So what about trailing zeros in a number with a decimal point? say in this case. So these trailing zeros are significant. These trailing zeros are significant. What about 0.06900? What about this? These are not significant, but these two zeros are significant. Okay, these two zeros are significant. Now let's take one confusing problem. Suppose the length is reported to be 4.700 meter. So length is 4.700. Okay, so it can be written as 470.0 centimeter also, and it can also be written as 4700 mm. It can also be written as 0.00470. Okay, now to remove, okay, so let us check how many significant digits are there in each of these lengths which are shown in different units. Okay, so this has four significant digits. Okay. This has got four significant digits, right? This has also got four significant digits, right? But this has only two significant digits as per the above rules. Okay, so which is this rule? This one, right? 8468. To remove such ambiguities, okay, so these are ambiguities. The best way is to report every measurement in scientific notation in power of 10. Okay, so we have to make it in scientific notation, a into 10 to the power b. Okay, so this is the notation which we have to consider. Now let's see how. So now how can we write this? So 4.700 meter can be written as 4.700 into 10 to the power 2 centimeter. Okay, it also can be written as 4.700 into 10 to the power 3 mm. It also can be written as 4.700 into 10 to the power minus 3 kilometer, right? So the power of 10 is irrelevant to determination of significant figures, right? So these power is insignificant to determining the significant figures. However, all the zeros appearing in base number in the scientific notation has four significant figures, right? There are four significant figures. So in scientific notation, no confusion arises. Okay, there is no confusion in determining the significant figures. Okay, now one last is the multiplying or dividing factors which are neither rounded numbers nor numbers representing measured values are exact and have infinite number of significant digits. So let's say example 2 pi r. Okay, so here this 2 has got infinite number of significant digits. It means that it can be written as 2.0, 2.00, 2.000 and so on, right? So wherever you find such exact numbers, it means it has infinite number of significant digits. Okay, so tomorrow we will take up rules for arithmetic operations and figures, right? So guys, stay tuned tomorrow.